Okay, continuing with the 0580 paper from February, March 25, 1-2 paper, non-calculated, paper 1. Let's see what they've got in this question. So once again, students failed to score particularly highly. First question is about a triangular prism. Triangle with depth. Uniform cross-section. If this was like a loaf of bread and you were cutting it like this, you'd get exactly the same shaped slice. That's what you get from all prisms. Let's see what we've got here. We've got some lengths, 6 centimetres, 6 centimetres, so this base is actually a square. And we've got this mark here and this mark here, which means it's isosceles. It means that this length is the same as that length. And I've got a height of 4 centimetres, and this information is all written down here. The prism has how many faces and how many edges? Well, the faces are the flat bits, and you've got to include the ones which are hidden. So we've got this sloping side, we've got the sloping side at the back, and we've got the base, that's 3. And we've got the front triangle and the back triangle, which is another 2. So for faces, I've got 5 faces. This is going to come important later in the question. Edges, once again, include the hidden ones. What you can do as you go around it is to sort of just make a little mark to say you've counted it. So 1, 2, 3, 4, 5. Those are the ones which we can see. 6, 7, 8. And we've got them all now. 5 faces and 8 edges. Show that the length of BC, that's this length here, is 5 centimetres. Well, I'm sure your maths teachers have all gone on about this particular triangle at length. Pardon the pun. The most famous Pythagorean triangle. Not to scale, but if I've got sides of 3 and 4, I always know the hypotenuse is 5. And somewhere on this non-calculator paper, this is going to come up. 9 times out of 10 at least. So let's see what we've got here. Well, let's see where this triangle is coming in. Now, I know I've got a right angled triangle. There's a right angled triangle here. Because if this is isosceles, this line dropping down to the bottom is a perpendicular, which means it's at right angles. And it's also going to cut this length into the same as that length there. So from here to here is the same as from here to here. Notice how I've used 2 lines here, because this length here is very probably going to be different to that length there. I can only use the same symbol to indicate the same length. Let's have a look at what this triangle now appears as. So I've got C is up here. I've got my right angle here. I've got B here. So I'll call this the middle here, call it T, any letter will do, it's not necessary. But anyway, it is a right angle. And I know this is 4 here. And the point is that this perpendicular here has cut this length here of 6 centimetres into 2 pieces, 3 centimetres each. Here we have a 3, 4 right angled triangle. The short sides are 3, the short side is 4, just as here. This length here is going to be 5. But it does say show that, so it's probably a good idea to use Pythagoras in here. So Pythagoras tells me that the hypotenuse squared, now the hypotenuse is this length BC, which we're asked to find in the question. So BC squared, the hypotenuse, is equal to, if you like, CT squared. If you want to be really mathy about this, you'd start off by using the letters from your diagram. You would then substitute in the numbers, evaluate, add them both up, and then square root. And that's the important thing to see from the examiner's report. They wanted to see this square root of 25. Common mistakes which were made were, I don't know, let's see, what could they have done? was rearranging badly from here. But in reality, if you had sketched out a 3, 4, 5 right angled triangle, you should have got your marks. Always back it up with full method though. If we're getting this clue of show that, be very, very clear, not just give me the answer. That's not what show that means. We then went on to do a question of a net, about a net. Now the simple fact is that teachers hate teaching nets because it involves getting a shape and cutting it up and things like this. I'm just going to take it that you know that a net is something which you can fold up to make a three-dimensional shape. And it wants a net of this. Now this is a three-dimensional shape, but if I was to draw this out on paper so I could fold it up, what would it look like? Well, let's have a little think about how we're going to need, you see it says 5 faces there, we're going to need to have 5 shapes on our net. 5 shapes in the net. And what are these shapes? Well, I've got a front and a back, and I'm going to need 2 triangles. I'm going to need that. I'm going to need my base, which we've seen is that square on the bottom. And I'm going to need this side, and I'm going to need the back sloping side, which is exactly the same. The 2 sloping sides. And this is why we've in fact calculated this length here as being 5 centimetres, because we're going to need to know the dimensions of each rectangle which makes up these 2 sloping sides. So these are going to be, in essence, these are our 5 faces which we're going to have to get on our net. And they've got to fit onto this grid. And here's your next clue. There's no space above. There's nothing, you're not going to draw anything above. Everything's got to go below. What do we need? Well, attached to this square base, I've got a triangle here, which has got a base of 6 centimetres, and it's got a perpendicular height of 4. Now, 1, 2, 3, 4 on both sides. That's where it's going to be drawn. We can't put on these 2 sloping sides, can't put on that there, because this measures 5 centimetres by 6 centimetres. And even if we say, well, let's have this 6 centimetres being the same as that one, we can't fit 5 off to the sides. And because it says complete the net of the prism on the 1 centimetre grid, that means we can't extend the grid. We've got to get it on what we're given. So what I'm going to get then is that on each side of this base here, so if I go around labelling this, and it's a good idea, you always start at the top right hand corner, top left hand corner. You don't have to do this labelling, but it might make things more clear. So what have I got here? Well, I've got to get my triangle in, and my triangle runs from A to B. Now, I can't get my triangle on there, so what I'm going to do is I'm going to switch these around. I'm going to call that B, and I'll call that C, and now I can fit it in. So I've got this triangle here, 6 centimetres on the base, which is this 6 centimetres here, and it's 4 centimetres high to the point C, coming from the middle, 4 centimetres, goes to there. And because you're in an exam now, get your ruler out. And there we go. So we've got this triangle here, the ABC triangle there. Now at the back, I've got D, so then so I can call this, let me get this triangle on here at the back, attached to the base, so it's got to go here. So far so good, a bit wonky there, you won't lose a mark for that, but you can see you know what you're doing. So what I've got now, I've got my base, I've got that bit's done, I've got my front, I've got my back, and I've got to get these 2 sides. Now, once again, these 2 sloping sides have got one length of 6, which just fits in with this length here of 6. And we just calculated this length here is 5, and we need 2 of them. Well, 2 times 5 is 10. And why is that important? Well, you'll see that there's just enough space to finish this off. Going down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just enough space to fit it in. And this is what's going to happen. It's going to happen with anything, any drawing which you do on a given grid or a graph on your IGCSE paper. It's going to fit on the paper. And it's going to fit quite tightly. And remember, that was that 5 units length. And there we go. And our 5 faces. 1, 2, 3, 4, 5. And hopefully you could see that if you cut this out, you folded these up, and you took that and you could fold it round, and you would get the shape. Thank you for watching.